Welcome to the Reduced Cyber Risk Podcast, episode 68, OSI Model versus the TCP/IP Model. Welcome to the Reduced Cyber Risk Podcast, where we provide you the training and tools you need to pass the CISSP Exam while enhancing your cybersecurity career. Hi, my name is Shon Gerber, and I'm your host for this action-packed, informative podcast. Join me each week as I provide the information you need to grow your cybersecurity knowledge so that you're better prepared to pass the CISSP exam. All right, let's get going. Hey, y'all, it's Shon Gerber with ShonGerber.com and the Reduced Cyber Risk Podcast. I hope everybody's doing well this beautiful week in February, as I just can't believe how fast the month is already going. It's just absolutely blowing my mind. I was talking to my wife just the other day and how she had said she works in a school system, not for long, but she works in a school system here in the United States. And in that school system, they have just been, the month of January just drug on. And one of the facts is it's the longest month of the year, and just dealing with children, that's enough to drive you crazy. But that being said, she said it's the longest month of the year, and with what I do for a living in cybersecurity, and as the Chief Information Security Officer for a multinational, I said to her, there is no way that this was a slow month. January blew by like a blink of an eye. It's just crazy. And one of the things I think is interesting is that as we have this coronavirus that is rolling and spreading throughout the globe, the taxing, I was talking to a gentleman the other day that he had said that he was surprised, or companies now are realizing how much or how little they had in place when it relates to their remote access and allowing third parties, or even now in the case of employees, to work from home due to the fact of the coronavirus. So it's something as you consider as you're working on your CISSP and you're coming up with different solutions, as you move up the chain and become different roles that you may be looking for in cybersecurity. If one of them is an architecture role, you'll have to come up with different ideas on how to best provide the capability for your business. And remote access is one of those, and especially now it's becoming more and more clear that allowing individuals to stay from home, especially during these outbreaks that there potentially could have, is really an important aspect. So if you haven't done it yet, if you're working at a IT shop that doesn't have this capability, you may want to consider it. It's just something to consider. How would you do that? Or even talk to the people that you work for. How would they work with a remote a work from home group of people? We've had some people some CEOs don't really like the work from home strategy, and it may not be the best for every company. However, in the event of something like this, you probably need to have it, just in the event that you've got something to fall back on in case something happens with your workforce and they can't come into work. So, kind of interesting. I would consider that in your repertoire of different items that you can provide in cybersecurity, as well as just good knowledge to know that it's a good capability. So, for today, we are going to get into the OSI model, and we're going to kind of go against what the TCP/IP model are. That's not right. They're R for plural, yes. But the OSI model and the TCP/IP model, they are very valuable in what we do on a daily basis. Now, you probably hear about the OSI model because you're studying for your CISSP, but I had no idea what the OSI model was when I first started into cybersecurity. I had heard of TCP/IP, but never really understood anything about the OSI model. So we like to call it the 7-layer burrito is for the OSI model. And so my 7-layer burrito versus TCP/IP is what we're going to kind of talk about today. So I'm going to pull an article from a company that's on the web called EDUC, as in Charlie Bravo Alpha.com. That's Echo Delta Uniform Charlie Bravo Alpha.com. And this is the OSI model versus their TCP/IP model. Now, when they talk about there, that both of these models are widely used communication network protocols, and I would agree with that. I would say that they're widely used in the fact that OSI is the foundation of what many kind of stood up as what we should plan for when you're dealing with an actual overall model. And when we talk about a model, what does that mean? It's basically just a structure of how should things networkly communicate. And so therefore, this model of the OSI model was out there and gained traction, but then was eclipsed by the TCP/IP model. Now, the main differences between the OSI is basically the OSI is a conceptual model that is really not practically used for communication. And kind of back to my first point, it is used as a reference model that people use when they're kind of trying to scale their applications, but in reality, most people use the TCP/IP. I really have never heard of anybody that actually used the OSI model as they're building their applications, but hey, what do I know? There's probably somebody out there who has done that. I would be willing to bet there probably is, but the typical one that you see out in the world is the TCP/IP. Now, it will define how data is transferred in a network or in different architectures, and that's the purpose, right? So if you didn't have a model to go by, you'd have each person creating their own aspects, and so it would be really hard for an application who created how they want their communication, how they want their piece of application to communicate with other things on the network. It would be very hard for switches and routers and so forth if they didn't have a model to go by on how which to send the data packets around. So it's important to understand that that's why that they came up with these frameworks, these models, so that the industry manufacturers had something to go by. Now, the TCP/IP model is widely used for link establishment and network interaction. You hear about that all the time. I don't think there is anything really else that would come close to TCP/IP. Now, obviously, there are different connection models that are available. You've got your standard UDP and as well, but there's it's an aspect that you need to consider is that it was used specifically for establishment of network interaction. Okay, so we're going to get into what the OSI model, that was kind of an overview of how the OSI versus TCP/IP. So the OSI model is a conceptual model, which we kind of mentioned earlier, and it was developed by the International Organization for Standardization. And it was designed for various communication systems to communicate through a standard protocol or a framework or just a standard of some kind, right? And it's broken down into 7 various layers. Hence the 7-layer burrito. If you're from the United States, there's a company called Taco Bell, which provides, I don't know what I want to call it. It's the Mexican type food is what they call it, but it is not anywhere close to that. I had a kind of a story when I used to fly airplanes. A gentleman I flew with, it was from Italy, and in the United States we have a restaurant called Olive Garden, and Olive Garden has got good Italian food for what people who don't really know what Italian food should be. And so we had Olive Garden. We made this comment to him, and I can't remember his name, but we said, hey, let's go to Olive Garden and go have dinner. And he looked at me and he said, are you kidding me? And I'm like, what are you talking about? And he goes, I said, Olive Garden's awesome. And he's like, no, Olive Garden is not awesome, especially if you're Italian. He said, that is like, and no offense, McDonald's, it's like the McDonald's of Italian food. Yeah, so hence, I've been able to fly to various parts around the world and had food in Italy. I had like a 20-course meal in northern Italy for when I was with the Air Force, and it was incredible. And yeah, so Olive Garden is not the best Italian food if you understand and have ever had really good Italian food. So that being said, all of that being said was that Taco Bell, which is sort of okay, fast food, Mexican food, sort of, not really, in the United States is they came up with a product called the burrito, this 7-layer burrito. And hence the fact is that the OSI model is the 7-layer burrito. And so starting off, the application layer is the first layer of this burrito. And it is the top layer, right? And it's designed to integrate with applications. Now, something to note, though, is that software applications are not components of the application layer. They got the same title in the name. However, that is not they're not part of the same layer. It's just that is the layer, I hate saying layer multiple times, but that's the level that communicates specifically with the applications. So it's an area that will provide you from the whole stack, from basically going all the way down, all the way to top, right? So, and it starts at the bottom with a physical layer and it works its way up. And in the application layer, it just states that it allows applications to communicate with it. The application layer is accountable for protocols and information manipulation on which the software users are relying to obtain significant information. What does that mean? Well, it's basically the protocols that allows it to communicate between the various applications. It is responsible for that. It provides all of the information that comes in and out of the entire stack. Now, the second layer as you head down is the presentation layer. Now, this is designed to prepare information so the application layer can use it. And basically what ends up happening is the data goes coming up from the bottom and working its way to the top. It'll come up through the next layer below is a session layer, and the session layer will have certain aspects around it. And so it'll come up and it'll present to the presentation layer. And this prepares the information so that the application layer can actually use the information and provide it to various applications, software applications that it may be communicating with. It doesn't have to be software applications. It can be pretty much any type of application. Now, the two communicators may use different encryption methods to communicate, so the incoming data is converted to a syntax which the receiving device application layer can understand. Okay, so what can happen is they can use different encryption capabilities. One of the things to consider is that I wouldn't want to do that. You'd probably want to keep them the same. It does add additional overhead by adding in more various levels of encryption. If you stick with different strengths of encryption and different encryption methods, that can add overhead that will just end up slowing down your communication. So therefore, it's important that you try to keep them the same. The session layer is the layer below the presentation layer. This layer is used to open and close communications between two machines. Okay, so that's the one that will set up a session. And when you're dealing with TCPIP, which we'll talk about in a minute, that's where you get your ACK, your SynACK, all of that. All of those that start up one communication with one computer and a second communication with another computer. That is what happens at the session layer. This period of opening and closing of correspondence is known as the session, right? So it's like, hey, bud, how are you? Good. I'm good. How are you? That whole communication piece is done through the session layer. The transport layer, this flow control and error control is responsible for this layer. Now, it basically checks for any receiving of any errors and ensuring that the completeness of the received data and requests retransmissions, if not. It basically makes sure that the communication doesn't have bugs, that there's not running into issues. So I know one of the things with TCPIP is you'll get drop packets. As you're getting with drop packets, it can cause issues with, especially if you're dealing with video, broken pictures, that it will not be as, you get that kind of that wow, like, I don't know how to explain it, but that really weird talking if you have connection errors. Now, typically what ends up happening though is with when you're streaming videos that you'll see, like such as on Netflix and so forth, a lot of times they'll use UDP type communications, and as they use those UDP type communications, that would then not necessarily, it wouldn't be connection, it'd be connectionless, and therefore it's just a barrage of data packets that are coming in. And with that being in place, you don't run the risk of having these connection errors. It's designed to lose packets. It doesn't want to lose packets, but it's designed to lose packets. So if it does, you still get a communication stream that does come across the wire. The network layer allows the transfer of information between two distinct networks. Okay, so this is utilized the best physical route for information to reach its destination. And so that's how, I don't know that much to say other than that allows two hosts to communicate with each other through the network. The data link layer is a layer that collects packets from the layer and breaks them into smaller parts. Okay, so that's where it basically brings it up from the physical layer. It's breaking these packets from that layer, and it breaks them into smaller parts. Like the network layer, the flow control and error control is interconnected. So again, there are aspects around making sure that the data that goes to and fro is done in a way that allows it to be communicating. So that's the whole point of it. And then the physical layer. This layer contains the physical devices such as wire switching, etc., etc. This is the bottom line where the ones and zeros, or the matrix that you see on TV, you know, the green little matrix stuff that's floating, that's in the physical layer. So you have a 7-layer burrito, and it starts at the bottom with the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and pops out of the top at the application layer. Okay, so that is the OSI model. Now, we're going to roll into the TCPIP model. Now, the TCPIP model, you have 4 layers. Okay, so this one here is what, again, considered the robust network protocol model. big words is the fact that it is considered, it's the industry standard. Most people use it, TCP/IP, and there's various versions. Obviously, there's different IP schemas for IP version 4 and IP version 6, but bottom line is the overall framework of TCP/IP is what is primarily used throughout the world. Okay, so the TCP/IP model is primarily known as established as the primary model to be used for any sort of network communications throughout the globe. Most people use TCP/IP. Like I've mentioned before, I don't know of anybody that really uses OSI, but TCP/IP is the primary one. So as you're dealing with the TCP/IP model, and in the past we used to deal with IP version 4 and IP version 6, the different IP models that are just how the data packets are set up. So you've got the 4 octets for the IP version 6, and then you have the gazillion for the IP version, or the IP version 4 is the 4 octets, and then the IP version 6 is 6 octets. But how the difference is in how many IP addresses is staggering, how many versus IP version 4 and IP version 6. The interesting part about all that is as we go into IP version 4, they were set up that we were going to run out of IP addresses, which is true, especially with everything that was connected. But they've done a lot of things with internal networks that there really isn't as big of a deal as they initially thought, because guess what? If they can find a way, they will, to fix the problem, and they did. But it's important to move, as everybody is moving away from IP version 4, they are moving into the IPv6 model, and that is just adds a little bit more complexity that we really hadn't anticipated. But now in today's world, the communication tools are so good that they can give an IPv6 IP address in no time at all, and it's really not much for people to have to mess with. So with the TCP/IP model, we're going to start with the application layer, and we're going to work our way back down. Now, the application layer, it performs the task of the OSI in 3 specific layers: the application, presentation, and session layer. So to put a little perspective, is they then combine, versus having 7 layers of the 7-layer burrito, they have a 4-layer burrito, and they combine the layers. So instead of that 7-layer burrito where you have beans and you have guac and you have all these other areas that basically are on top of each other, they just mix them all together and they put them into the paste. So it's not the same as the OSI model. I probably just totally distracted you all with that comment, but that's okay. We're all right with that. So the application layer, again, it combines the application, presentation, and session layers together. The transport layer, this allows information to be delivered on an information chart format from the source to the destination host without defects. Again, very similar to the transport layer that we've talked about in the OSI model. It's again when you're dealing with transport, and then we talked about transport and data link in the OSI model do error checking. But again, the transport layer does the same type of concept, so that one stays the same. But the application layer, which is the one above it, dealt with the application, presentation, and session layer. Now, the internet layer is used to send independent packets to a network destination. Okay, again, that's kind of where we're getting into the whole network layer that was within the OSI model. Now, again, all machines, web servers, nodes are all attached via TCP/IP connections, and that's where they occur over the internet layer. Then the last layer is the network access layer. This is a combination of the data link and the physical layer available in the OSI. And this is done, the physical addressing is done through MAC addresses, source and destination as well for the data packets. So that's the key piece around the OSI model. So that's the one that's primary. The network access layer is primarily designed for the physical transmission of the data. So because you see, you go from the TCP/IP model, which is 4, or from the OSI model, which is 7, to the TCP/IP model, which is 4. So there is some change, and I like less is better. Just the simple fact is, if you can keep it simple, it's important to do that. I like the KISS principle, because it's KISS principle, if you're not aware, is keep it simple. And then you could say stupid, you could say smarty, you could say however you want to say it. But bottom line is you want to keep it simple. Now, the key differences between the OSI and the TCP, and these are some things that they talked about in this article, is that the horizontal approach is known for the OSI, and the vertical approach is known for the TCP/IP approach. Bottom line is that the OSI will scale sideways versus TCP scales up and down. The OSI is a protocol independent and very generic, which we've talked about. It's a generic protocol. It's designed as the framework kind of to design. If you're going to go down something, you at least would focus on the OSI model if you're designing something that would need some sort of network connectivity, but TCP/IP has the normal laws that support internet development because it's been the standard for so long. Basically, the TCP/IP is extremely reliable. I mean, you think about it, you just plug something in and it works, and that protocol is in place, whereas the OSI would add a lot of complexity if you wanted to integrate that within your network. The difference also is the OSI model presentation and session layer is available, while the TCP/IP model does not have such a layer, because basically it combined them and put them all under the actual one of the application layer. There's no other model is TCP/IP, while OSI is attempting to match other model designs because it is a reference model. That again, TCP/IP is the known standard out there. Protocols can be easily terminated while the original rules are in the TCP/IP model. New ones can be introduced in the OSI model. So those are some key differences that they have. Now, one thing that they had also put on the website as well that are some basically OSI versus TCP/IP. The OSI stands for Open Systems Interconnection, so that will probably be on the CISSP test, I would expect. Now, they'll probably play some trick mind games with you and call it the Open Sector Interconnection or something like that. If they're going to ask you a question, it will be something to try to trick up your mind to make sure you understand that it's Open Systems Interconnection. And then the TCP/IP is obviously Transmission Control and Internet Protocol. They'll ask you stuff like that, or they may not ask you that specific question to say what is it. They may put that in the title or in the question itself, which will maybe throw you off if you're not sure if they're trying to mess with your mind on that. So that understand what and I would really consider understanding what each of those terms means, just because that is a really good way to trick somebody up, is to give you different types of acronym names rather than just going with the standard acronym of OSI. It's a theoretical framework. The OSI model is versus TCP/IP is actually in service. OSI model has 7. TCP/IP has 4. The OSI model is not used much. TCP/IP is used a lot. And so those are some good ones right there. The model delivery of the package is a guarantee, so that's on the OSI, but it's not necessarily always assured in TCP/IP, and that's true. You will lose packets in TCP/IP, but the one thing to keep in mind around that is that because it is the connections that occur, usually you can get away with lost packets. Not a lot, but you can get away with a few. Okay, that's all I have for this article, and that came from educba.com, OSI model versus TCP/IP model. So we're going to roll into my specific training around the OSI model that I have that covers the objectives in the CISSP exam. But before we do, you need to go to ShonGerber.com and check out my CISSP mini course. You can sign up for my email list, and with that, you'll get my CISSP mini course. It's basically 8 different videos that come specifically out of my training that I provide, and that's going to walk you through what you should know for the CISSP exam. I've also got some free content that will come in of how you should study for the CISSP exam and some key tips you need to know as you are getting prepped to take the test. The best part about it is that you will be able to get exam questions that'll come with it. I'll have those as well. So there's a lot of great stuff you have just by going to sign up at ShonGerber.com. That's SHON Gerber, GERBER.com. All right, so let's get into the CISSP training that I have around the domain 4, and this is 4.1 Objective Internet Protocol Networking of the CISSP exam. Okay, this is CISSP training for ShonGerber.com. This is Domain 4, Objective 4.1, Internet Protocol Networking. So now, as we talked about the TCP/IP and the OSI models, one thing to consider is the TCP/IP model was created before the OSI. And they do have different layers, which we talked about, versus the 7-layer burrito in the OSI model versus the TCP/IP 4-layer burrito / taco. We'll go with 4-layer taco. The burrito versus the taco. So we've talked about the differences and how in the TCP/IP, there's the 4 is you've got your link, internet, transport, and application layer. And then also in the OSI, it basically transports. So your link is your physical and data link. Your internet is your network layer, your transport layer is your transport layer, and your application layer is the session, presentation, and application. So we kind of talked about how those map across. Now, the one thing to consider on the security of TCP/IP is you have various security mechanisms that will help you. You have your virtual private network. So if you're not familiar with what one of those are, it's basically a VP, or it's a tunnel that goes between you, your device, and your internal network. And you become, in all senses, a node on your network when you have a VPN connection. So you could be sitting at home, connected with your VPN. And again, this is all old stuff to you guys. I know you guys understand this, but bottom line is you can sit on your computer and you can log into your enterprise network or whatever network you want with a VPN connection and or tunnel, and you have a secure connection between 2 points. Now, there's also a security aspect. Another part of TCP/IP is PPTP, which is your point-to-point tunneling. That's another one. It's very similar to VPN, but it's a little bit different protocol that's in place and allows you to have a connection between two physical devices. You have Secure Shell, which is your SSH, and then you have Internet Protocol Security, which is your IPsec. They all work pretty much the same type of way. The VPN is typically used because it gives you a little bit more flexibility, but they all can be used in very similar manners. I've used IPsec tunnels between two devices, especially when you have regulatory requirements around that, and you want them to be connected in a secure manner. An IPsec tunnel can be connected between the two devices. You also have a TCP wrapper, which acts as a protocol firewall. Basically, what it does is it has port restrictions, so you wraps that TCP packet up, and it does limit what you can do with it, or I should say it acts like a firewall, where in the fact that it's not it's not wide open. There are port restrictions on that specific TCP wrapper. Communication modes, there are different types of communication modes, and we had talked about this earlier. You have your full duplex, which is your TCP/IP, and that means duplex basically means communications back and forth, and you have your simplex, which is UDP. So the communication to kind of look at is like a walkie-talkie. With the duplex, they talk back and forth, whereas the simplex is just broadcasting, kind of like this podcast, right? I'm not really, but sort of kind of. If you're like on your radio, if you're dealing with your radio and you turn on your radio to listen to music, that would be a version of a UDP packet. I'm not saying that that is a UDP packet, but that would be similar to what that is. It's just broadcasting out streams of data to you. Now, as you're dealing with the different various communication ports that are available when you're dealing with TCP/IP, where it was over 65,536 ports. Okay, so if you're trying to use, and one thing I would like to recommend to you guys is that are studying for your CISSP is you talk to senior leaders. We talked about this before on this podcast. It's important that you break it down to the third grade level. And I don't mean for you to tell people that I'm so smart and you're a third grader. No, that's not. Don't do that. That will hurt you when you're trying to influence people. That will be a bad thing. That is not something you want to have happen. But what you want to do is communicate this to individuals and let them know that, like, and I like to use this example, is there's a vent or a piece of mesh or like a net that you would use to catch fish. And in that net, there's approximately 65,000 holes in this net. And the whole purpose is that you want to plug up as many of those holes as you possibly can. And so that only a few holes are actually communicating over. And so as you have a TCP/IP connection and you're communicating with another instance, there's those 65,000 holes are open and available. Now, what you want is you want applications that actually utilize only a few of those ports, of those holes, when they communicate. And so therefore you want to lock down as many ports as you can. Now, some of those ports have standard communication paths. Some of them do not. So many applications will, if they're a certain type of remote desktop type application, they will use a specific set or range of ports. If they're another types of applications, they typically use another set of ports. However, you can communicate over the internet over port 250. You can communicate over the port 22,362. They have a typical ports for it. Let's just use internet for an example, where it's port 80 or port 8080. Those might be in place, but the simple fact of it is typically they are used over port 80, and your SSL is typically used over port 443. So those are the actual communication paths that occur. Now, from 0 to 1023 are well-known ports, and that's what typically people put them on. However, I have seen that if there's an application that requires multiple ports for communication, so let's say, for example, it has a lot of people that can connect to it, and it has to communicate via a port, it will put out a range that would be pretty substantial, maybe potentially 2,000-3,000 different ports that could be open that application must communicate back through. So that you'll get ranges. They don't always just go over one specific port like 443. But the one thing to consider is that is how I would communicate to individuals about what is this port thing, because all it will do is confuse people. And if you can then tell them in a way that's understandable and easy to digest, you will win friends and influence people. There's a really good book you should read from Dale Carnegie on how to win friends and influence people. Very, very good book. Another good book, if you're looking for those, is a book called Skill with People, and that's by Les Giblin. It's a really easy read. It's the kind of read that you can, it's bathroom reading, that will take you 30 minutes or to read the entire book. That's about it. So, yeah, I mean, through a couple different bathroom visits, you can have that whole book read. I know it's probably gross, but it's true. And you can read that entire book, and it's really good daily activities that you can use on how you communicate with people. It's just awesome. So the last thing I want to talk about is the SynACK Dance. So this is the three-way handshake that occurs when a TCP/IP packet does connect. And this SynACK Dance works this way. So basically what will end up happening is there'll be a synchronization packet will be sent to a server or an application, whatever that, or not an application, but to a server. And that server then will respond with a SynACK, which is your going, yeah, you know, like in the case of the Muppets, they would act. It was that Bebop. I think it was Bebop. Can't remember that guy's little name. It was that little dude that would just go beep, 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 beep. So he would act. He would say that, yes, I'm here. I'm here. I'm talking to you. So your SynPack would be sent. Then your SynACK would kick in, and the ACK would tell you that, yes, I acknowledge your existence. And then the client would respond to the ACK. Now, there's other resets, or not resets. There's other flags that are used to trigger this as well. So you have there's also the fin, there's a reset, and these flippers, I can't think of the name, I'm struggling with the name, but there's basically these triggers that will then help with the communication path between both parties. So you have your SynACK, and then your ACK. And all of those will help make a communication between the TCP/IP communication stream work. So they're important. I like to call it the SynACK Dance, but that's really what it is. It's a three-way handshake between the two. All right, so that's all I have for today. We're going to roll into some CISSP questions. Okay, so the CISSP question. In what type of software testing does the tester have access to underlying source code? A, static testing. B, dynamic testing. C, cross-site script testing. D, black box testing. Not texting. We don't want black box texting. What is it? What type of software testing does a tester have access to underlying source code? Static testing, dynamic testing, cross-site script testing, or black box testing? All right, so you'd want to go through and you want to knock out some of these that you'd think are like, no, that's not right. So that one with IFCB, cross-site script testing and black box testing don't really fall into the bucket of what you're looking for. So then you got to bring it down to is what does it happen to deal with the underlying source code? Dynamic testing is typically done when they're doing user acceptance testing and they're trying to play with the product. Static testing is they're just testing one piece of code, and that would be under static testing. So basically, in order to conduct a static test, the tester must have access to the underlying code. And that's from Brainscape. All right, next question. What portion of the change management process allows developers to prioritize tasks? A, release control. B, configuration control. C, request control. Or D, change audit. Okay, so what portion of the change management process, which is very important, by the way, allows developers to prioritize tasks? A, release control. B, configuration control. C, request control. Or D, change audit. And the answer is C, request control. The request control provides users with a framework to request changes and developers with the opportunity to prioritize those requests. So that's a very important thing, and you put it in depending upon how you do your development. You could be an agile method where you would then put in user stories based on that and then requests for that. That's from Brainscapes as well. Which one of the following key types is used to enforce referential integrity between database tables? Okay, that's a lot of big $10 words in there. So, yeah, we're going to say that one more time. Which of the following key types is used to enforce referential integrity between data table types? A, candidate key. B, primary key. C, foreign key. D, super key. I like the super key. That's probably not right. Which of the following key types is used to enforce referential integrity between database tables? A, candidate type, or candidate key. B, primary key. C, foreign key. D, super key. And the answer is C. Not C. It's not C. It's C, foreign key. Foreign keys are used to enforce referential integrity constraints between tables and participants in a relationship. Foreign key. That's actually a new one for me. I didn't know that. So that's pretty cool. Foreign key. See, you can learn something new every day. Don't let anybody tell you that they've got it all figured out, because guess what? They're lying to you. They don't. And that one other piece of information before we quit. If you go into a meeting and you're confused about something and you don't understand it, ask the question, because guess what? I guarantee you there are people in that same room that are confused about the topic, and they're just not going to lead on because they don't want to look stupid. I tend to look stupid on a daily basis, so that looking stupid is a good thing. It's a very good thing. All right, guys, I appreciate your time today and hope you enjoyed this podcast. You can always check us out at ShonGerber.com. That's Shon, S-H-O-N Gerber, G-E-R-B-E-R.com. And we've got some great stuff out there. My CISSP mini course, domains 1 through 8, it's available for you for free. All you got to do is sign up for my email list. All right, have a great day, guys, and we will catch you on the flip side. See ya. Thanks so much for joining me today on my podcast. Head over to ShonGerber.com and look at all the free content that I have available for you. There is a CISSP mini course, free CISSP exam questions, podcast, and so much more. It's all available to my email subscribers, so sign up. If you want my personalized CISSP training, purchase my training courses, and I'll be there to help you with your CISSP needs so you can pass the test the first time. Thanks so much for listening. We'll catch you on the flip side. See ya.